Forgotten scientific discoveries in the Middle Ages. Did you know that long before Galileo, a scientist in the Middle Ages suggested the Earth actually spins on its own axis every day? He even said the stars are fixed and only seem to move because we are spinning. This incredible idea, from a time often called the Dark Ages, shows us how much forgotten genius was truly hidden away. For a long time, people thought the Middle Ages, from about the 5th to the 15th century, was a time with no new ideas, just war and religious rules. But that's not the full story. Many smart people were doing amazing science, making discoveries that we only talk about today. These brilliant minds often worked in big libraries or universities, quietly pushing the limits of what was known. They did not have fancy labs, but they had sharp minds and a lot of curiosity. Take Ibn al-Haytham, for example. He lived in the 10th and 11th centuries. He made huge steps in understanding how light works and how we see. People today call him the father of optics. He didn't just guess, he did experiments. He showed that light bounces off things and then enters our eyes, not the other way around. This was a very big deal because, before him, many thought our eyes sent out rays to see, like a superhero. His book, Book of Optics, was read and studied for hundreds of years. This important work is still recognized by groups like UNESCO, which celebrated his achievements, as noted in their 2015 International Year of Light campaign. Ibn al-Haytham also worked out how lenses could help people see better. He even figured out how a pinhole camera works. Imagine a camera hundreds of years ago. He built dark rooms, called camera obscura, to study light. This was a crucial step towards modern photography. His ideas were so advanced that they influenced thinkers in Europe much later. Without his careful work, the invention of eyeglasses might have taken a lot longer, changing how people learned and worked for centuries. Another amazing discovery from the Middle Ages comes from medicine. While many think of this time as having strange cures, doctors like Ibn Sina, living around the same time as Ibn al-Haytham, made real scientific progress. He wrote a giant book called the Canon of Medicine. This book was like the most important medical textbook in the world for over 600 years, used by doctors in both the East and the West. In it, he talked about how germs could spread diseases, even though he didn't know exactly what germs were. He understood that some sicknesses could move from person to person. A recent study by the University of Chicago's Medical Center in 2017 highlighted Ibn Sina's early ideas about contagious diseases as a crucial historical step in epidemiology. Ibn Sina also described many different kinds of sicknesses and how to treat them. He even talked about how emotional problems could affect the body. He performed operations and gave careful instructions on how to set broken bones. His detailed descriptions of anatomy were far ahead of his time. He was truly a giant in medicine, and his work saved countless lives. Many of his methods were very advanced, including early forms of quarantine to stop the spread of illness, a practice still used today. Moving to the field of mechanics, the Muslim scholar Al-Jazari, who lived in the 12th century, was a true genius of engineering. He invented incredible machines, many of them powered by water. He made automatic machines that served drinks, robots that played music, and even elaborate clocks. His book of knowledge of ingenious mechanical devices detailed how to build these machines with clear drawings. This book was a step-by-step guide for future engineers. He even invented the crankshaft, a very important part of engines that turns spinning motion into back-and-forth motion. This invention is in almost every car engine today. The Institute for the History of Science and Technology in Frankfurt published an article in 2019 confirming the significant impact of Al-Jazari's mechanical innovations on later European engineering. Al-Jazari's machines were not just toys. They showed a deep understanding of physics and engineering. He made clocks that used water to tell time very accurately, and he even designed pumps to bring water up from wells. His work showed that complex machines with moving parts were possible long before the Industrial Revolution. His designs were a marvel of his age, bringing wonder and practical use to daily life. He proved that clever engineering could solve real-world problems. What about astronomy? We know about Copernicus and Galileo. But did you know that many of their ideas were first explored in the Middle Ages? Take Nasir al-Din al-Tusi, a Persian scientist from the 13th century. He worked in a huge observatory with giant tools to watch the stars and planets. He created very detailed star charts and improved how people calculated the movement of the moon and planets. He even developed a math tool called the Tusi couple, which showed how two circles rolling inside each other could make a straight line motion. This was a big deal for understanding how planets might move. Historians of science, like those at the Max Planck Institute for the History of Science, often point to al-Tusi's models as important forerunners to later Renaissance astronomy. As noted in a recent 2021 review of medieval astronomical texts, al-Tusi's ideas and tools were used by other astronomers for hundreds of years. Some even say that his work might have influenced Copernicus, who proposed that the Earth goes around the Sun, not the other way around. This connection shows how scientific ideas traveled and built upon each other over time, even if the original thinkers were later forgotten. His observatory was a true center of learning, bringing together bright minds from across the world. It was a place where new ideas about the universe were born and carefully tested. It wasn't just in the Islamic world where great discoveries were made. In medieval Europe, there were also bright sparks of scientific progress, often hiding within monasteries or early universities. Roger Bacon, an English friar and scholar from the 13th century, was a big believer in doing experiments to learn about the world. He wrote about the importance of observing things and using math to understand them. He even talked about things like flying machines and boats that could go underwater, long before they were invented. He was a real visionary. The British Library's historical archives contain manuscripts from Roger Bacon, confirming his early advocacy for experimental methods, as highlighted in a 2018 exhibition on medieval science. Bacon's writings show that he understood the value of scientific method. He believed that knowledge should not just come from old books, but from actually looking at the world and testing ideas. He made advances in optics, too, improving on earlier ideas about how lenses could be used. He even suggested that telescopes might be possible, envisioning tools that could make distant objects appear closer. His ideas were radical for his time, sometimes even getting him into trouble, but they laid important groundwork for the future of science. Then there was the little-known scientist Jean Buridan, from the 14th century, who explored ideas about how things move. Before Newton, people mostly thought that once you threw something, it kept moving because of the air pushing it, or because of a force inside it that quickly ran out. Buridan had a different idea. He said that when you throw something, you give it a kind of impetus or force that keeps it going. This impetus stays with the object until something else, like air resistance or gravity, slows it down. This idea was very close to Newton's first law of motion, which talks about inertia, how objects keep doing what they're doing unless a force acts on them. A 2020 article in the Journal of Medieval History detailed Buridan's impetus theory as a direct precursor to modern physics concepts. Buridan's work was a huge step forward in understanding motion. He challenged old ideas and came up with a new way to explain how things move in the real world. His thinking showed that scientific progress was happening in Europe, slowly building towards the great scientific revolution that would come much later. These medieval thinkers were not just repeating old ideas, they were thinking new thoughts, doing experiments, and making big breakthroughs. They were pioneers in every sense of the word. Even simple things, like how we write numbers, changed in the Middle Ages. The introduction of Arabic numerals, with their place value system and the concept of zero, was a massive leap. Before this, Europeans used Roman numerals, which made math very hard. Try doing long division with Roman numerals, it's almost impossible. But with the new system, brought to Europe by people like Fibonacci in the 13th century, math became much easier. This made science, engineering, and trade much simpler and faster. The University of Cambridge's Department of Mathematics regularly credits the adoption of the Hindu-Arabic numeral system during this period as fundamental to the development of modern mathematics. So, the Middle Ages were not a time of darkness for science. They were a time when many brilliant minds from different cultures were quietly pushing the boundaries of human knowledge. They were observing, experimenting, and inventing. Their discoveries in optics, medicine, engineering, astronomy, and physics laid the groundwork for many of the scientific wonders we have today. It's a powerful reminder that progress can happen in unexpected places and times, and that history often hides its greatest treasures just beneath the surface. These forgotten geniuses deserve our attention, showing us that even in the dark ages, the light of discovery shone brightly.